is Chris Posey. I'm the marketing manager at OGI Process Equipment. Today we will be talking about enhanced sanitation, specifically in the food and beverage industry. If you have questions or comments as the webinar proceeds, you can type those into the chat console on the right side of your screen. We'll also be posting a few questions there for you. If you don't mind answering those, we'd be very interested to get your feedback on those things. Good morning, Phil. So with that, I'm going to go ahead and turn it over to John Payne, applications engineer here at OGI.
Good morning, everybody. My name is John Payne. I'm the QuikWater engineer for the applications engineer for the QuikWater product. Today, we're going to touch on a few things, including what a direct contact water heater is and some of the basic operations. Next, we'll cover the QuikWater MegaHeater and when you would want to use them. After this, I'll explain our NSF certification and cover some food and beverage applications. And finally, I will discuss the information needed for us to quote the system for you. Direct contact water heating is a process used to heat water using the direct contact of the flue gases with the water being used for the process. Direct contact water heaters are able to achieve higher efficiencies due to this direct contact of the two streams. The large surface area for the heat transfer between the spraying water and the exhaust gas allows for almost all the energy from the exhaust stream to be transferred to the water. Typical heat exchange processes have several heat exchange interfaces, each interface having losses which reduce the overall efficiency of the system. Regardless of the manufacturer, direct contact water heaters operate on the same basic principles. A burner, typically burning natural gas or propane, is fired into the heater, providing the heat input into the system, while water is sprayed over the packing bed. With these basic similarities in function, there are some differences between different manufacturers of direct contact water heaters. The heat transferred from the gases to the water collects in the reservoir prior to being pumped to a process. Efficiency of the direct contact water heater is primarily measured by the stack temperature, as we'll cover in the next slide. This temperature is an indication on the heat captured. As seen in this curve, the efficiency and exhaust stack temperature are related by the efficiency curve shown in red. Exhaust stack temperature is a function of the inlet water temperature, as well as the condition of the heat transfer media. Stack temperature is typically 10 to 20 degrees over the inlet water temperature. As the media fouls, temperature difference between the inlet water and temperature of the stack will grow, decreasing the efficiency. As an example here, if we have 70-degree water coming into the heater, we would expect somewhere around a 90-degree stack temperature. And then if you correlate that to the curve, you're looking at approximately 97% efficiency. The flagship is the most common heater we sell due to the wide range of sizes and flow rates, anywhere from 10 to thousands of gallons per minute. Also, for most water process applications, the 180-degree maximum temperature is acceptable. To learn more about this heater line, please contact Landon or Chris to get a link to the previous webinar where we went in depth on the QuikWater flagship. Today, we're going to talk about the QuikWater MegaHeater. This MegaHeater is used in applications where the customer requires hot water over 180 degrees. The MegaHeater can effectively and efficiently produce water up to 200 degrees Fahrenheit. The MegaHeater is available in sizes from 450,000 BTUs per hour to 8.3 million BTUs per hour. Like the flagship, there are a wide range of controls and options available. The MegaHeater has a smaller tank volume than our flagship heaters. With this, they're typically best suited for steady state operations or in an application where you're going to use an external tank. If your process has an irregular flow demand, an external tank may be the best solution. When designing the application using an external tank, OGI can custom program the heater to monitor level and temperature in your external tank. The heater can also be set up to recirculate the external tank to bring the tank temperature back to set point in the event of a cool off. OGI can provide the sensors and pumps or can provide connection points and wiring diagrams so you can integrate the system yourself. The MegaHeater using direct contact technology still maintains its high efficiency. With the MegaHeater, we use a secondary heat exchange along the dry fire combustion chamber to achieve higher temperatures. The MegaHeater uses a Maxon burner, standard emissions for this, and like other QuikWater heaters, we use parallel positioning with full modulation. I'm going to touch on the QuikWater multi-tower. The multi-tower can be used to join any two or more heaters of the same product family together. They're typically the same size heater, however, depending on the demand profile, different sizes can be used. With the multi-tower, you can operate the system as two complete 100% redundant units or operate them together to reach 100%. For example, you can run two 50% units, which will double your turn down, saving energy on lower demand periods. This gives the system more redundancy across all of the parts on the system. The control scheme for the multi-tower sequences and controls the heater, pumps, and burners, which is a patented control system by OGI. The control scheme monitors the usage and determines whether each heater should run to even wear out between the two heaters. The QuikWater flagship carries the NSF certification when equipped. OGI carries this certification on the flagship product line. This certification will apply to the multi-tower flagship as well. QuikWater was the first direct contact water heater to get the NSF certification. NSF is certifying that the construction techniques, the material, and other trim components do not degrade the water in such a way that a human cannot consume it. With our NSF certification, we're regulated and receive a non-notified biannual audit. During this audit, NSF ensures that all materials are in compliance and records are kept from engineering through purchasing and manufacturing on any component or material that was used on that heater. When an NSF heater is required, the major differences on the wetted component side are typically the valves, pumps, and gaskets. Whereas the burner, fuel train, and other controls remain the same to a standard heater. Next, we'll dive into some QuikWater applications. Listed here are some applications for the food and beverage industry. In general, a QuikWater can be a higher efficiency alternative to a boiler for any hot water process that doesn't require steam. Using a flagship heater that is NSF certified, you can actually use the hot water product as an ingredient in a food product. By having the NSF certification, it can be consumed by humans. A few years ago, a large multi-tower unit was sold to a baby food manufacturer here in the United States, where the hot water product was used in the food ingredients. Most of these applications will be best suited for the flagship heater, which can heat up to 180 degrees Fahrenheit. However, some applications for tank warming, bottle sterilization, and hot water fill bottling will require hotter temperatures. For these applications, we would use the QuikWater MegaHeater. If you do require both a high and medium temperature application, it's also possible to achieve this with the MegaHeater. The high temp application can be run directly from the heater, and the excess process water can be blended down to a medium temperature and stored an external tank for this secondary process. The hot water loop is a fairly common application we see. In this, the QuikWater's heater's transfer pump is connected to the hot water plumbing that feeds anywhere from spray down hoses or some other applications. Typically, we suggest driving the pump with a VFD, controlling with downstream pressure. This allows the pump to maintain a set pressure on the hot water header as long as demand falls within the operating window of the pump. The VFD will slow down or speed up to maintain that set pressure on the header. At the end of the loop, typically it'll return to the QuikWater tank. There you can either use an orifice plate or a globe valve to adjust the amount of water that returns to the system when there's zero demand on the loop. Typically, this flow rate will be small enough to maintain loop temperature, but not so high as to waste pumping power. In this application shown here, we have a duplex pump system that was 2 pumps sized to 100% of the total flow rate. This allowed for redundancy in the system. As with the multi-tower system, OGI employs our control scheme that monitors run hours, start stops for each pump, and will wear balance the pumps to ensure the standby pump is not faulty when you actually need it. The heater will sense a failure and automatically switch over to the backup pump and alert operators of the failure. Some of the advantages of this system are the high efficiency of the direct contact water heater, as well as accurate pressure control on your loop and maintaining that set temperature on your loop. Another application we see commonly for certain industries is can warming. This application can be seen where you're bottling or canning beverages, particularly soda. We have many of these applications throughout the country running for over 20 years. In this canning process, the finished cans are cold, typically below the dew point of the air. In order to prevent condensation forming on the can and destroying the cardboard packaging, the cans are warmed up above the dew point temperature of the environment prior to packaging. This allows the cans to be packaged directly after coming off the canning line, preventing condensation from forming and destroying packaging and creating a safety hazard in your warehouse. Another similar application to this is fruit washing. This application has been very successful in the Northwest, particularly for apple washing, where we have units still operating over 20 years later. Both applications are similar in that the heater is pumping into a large bath, which is circulated over the product. On the external bath, there is a pump returning water to the inlet of the heater, where it is rewarmed prior to being pumped back to the process. We monitor temperature both in the external bath and on the heater itself. Installed downstream of the pump is a level controlling OCV valve. This valve is used to maintain the level of the water inside the QuikWater heater, where it opens as the level rises and closes off as the level drops. This valve is used in this process to prevent the heater from hitting either the high or the low float, both of which will interrupt the continuous process. Next, we're going to cover an external tank application. With the QuikWater heater, there are only a few applications where it makes sense to add a large external tank. Typically with a QuikWater, it's used on an on-demand application. However, there are some circumstances where it makes sense to add an external tank. Applications where there's an intermittent high flow and sizing the heater based on average demand, or if you're adding the QuikWater to an existing system with a tank. The decision on sizing the heater for using an external tank is the balancing basically of economic and process design. Adding an external tank to the design can double up on valves, instrumentation, and pumps. If an external tank is added to the system, the QuikWater can be set up to integrate with this tank. A QuikWater quoted and designed for the external tank will typically have a minimum of 3 level floats. The low is there to shut off the pump, preventing it from running dry. The high float is there to prevent the tank from overflowing, whereas the high float will signal to the QuikWater that there's a call for fill. In addition to level controls, a temperature sensor can be integrated to signal a call for reheat of the external tank if it is full and not up to set point. Once a call for reheat is signaled, a pump will pump water from the tank back to the heater and reheat and pump back to the tank. In addition to these controls, a pump skid can be designed and built and integrated into the QuikWater controls. The diagram over here shows an application where there's a single pump for recirculating the tank and pumping to the process. Alternatively, you can have a dedicated tank pumping back to the QuikWater for recirculation and one for the process pump. OGI has a fully staffed service department that is available 24 hours a day, 7 days a week, 365 days a year. Our service techs do a full test of each unit in our test bay prior to shipping each unit. Each unit is also set up with a combustion analyzer to ensure the burner is operating at the optimal rate. These same technicians perform site startups and maintenance in the field on your units once they are delivered. We also offer customized maintenance programs upon request. The final piece in this is covering the information required to quote. At a minimum, we need to know the flow rate, the inlet outlet temperatures, and the discharge pressure you would like to see leaving the heater. This will give us the size of the heater. If you have any other preferences of the equipment, this is the best time to specify it. One document we have for this is our application data sheet. This is essentially a worksheet for gathering information on the application. And that's available by contacting Landon. This is the conclusion of our webinar today. We appreciate you all taking time out of your day to learn more about QuikWater. If you have any questions, please type them in the window, or you're welcome to contact Landon or myself if you have any questions after the meeting.
All right, thanks, John. That's great information. This webinar will be made available to you on demand later today or tomorrow. And, I forgot to mention our QuikWater sales manager, Landon Nealon, a little earlier. You can talk to either Landon or John personally if you have any questions about QuikWater units, particularly with regard to application in your organization. This will probably be our last QuikWater webinar for 2020, but we will be starting back in 2021. So we hope to see you guys then, and do follow us on social media on LinkedIn, Facebook, Instagram, and Twitter. We constantly post information about QuikWater units in particular, and our other units that we produce here at OGI in general through those channels. I do see one question coming through now from Ty. Does carbonic acid become a concern? If so, how do you combat it? Continuous blowdown. John, are you able to address that question, or?
Sure.
Okay.
As far as carbonic acid, typically with our applications, it's a single pass through and there's very little accumulation, typically no measurable. So we have some studies based on water quality in, water quality out, that if you reach out to Landon, I'm sure that actually Landon can actually send that information to you. So we don't see that. The only time we see that typically is in a closed loop application where you're running a heat exchanger, or you're doing a tank warming, or some of these bottle warming, can warming applications. And typically there's just a scheduled blowdown where we just say, after X number of hours, or after they do pH testing of the water.
Okay, thanks. A couple asking for the more detailed version, and if I'm understanding correctly, I think that's what John was mentioning earlier from a previous webinar that kind of lays out some of the more foundational aspects of QuikWater in greater detail. And I can send the link to that out. Also, it's available on our website. You can actually access it just from our homepage at ogipe.com. But like I say, I'm happy to include both of our previous QuikWater webinars whenever I send out the on-demand version of this webinar. Looks like Dwayne has a question, and this may be one that we follow up with individually after the webinar. John, any insights on this, or should we just contact Dwayne directly on that one?
Sure. Yeah. I think Dwayne, Landon, and myself can get a hold of you after this, and yeah, we'll help you out however we can.
All right. Well, with that, I think we will go ahead and conclude. Like I said, I'll include a link to this webinar as well as our previous QuikWater webinars for everyone's reference. And hope the rest of your 2020 goes great, and we look forward to seeing you in 2021.